Hi everyone, welcome back to the Data Couple. So today we are continuing with the Leetcode 75 study plan, and today we are going to solve the second problem, which is the greatest common divisor of strings. Now, this problem is an interesting mix of string manipulation and mathematics, specifically the greatest common divisor concept. So I'll try to break it down step by step, try to give the logic behind the solution, and we will manually implement the GCD function using the Euclidean algorithm. Don't worry, I will explain the Euclidean algorithm with examples so that you get the grasp of it. So without further ado, let's dive in. So the problem statement is that we are given two strings, string 1 and string 2, and our task is to return the largest string x such that x divides both string 1 and string 2. Now what does this essentially mean? This means that we have to find the largest string x such that both string 1 and string 2 can be formed by repeating x. So for example, look what it says in the first example. So in the first example, string 1 is ABC, and in the string 2 it is given as ABC. So the output is ABC. Why? Because both string 1 and string 2 are made up of ABC. Now similarly, if you look into the next example, here we have string 1 as AB and string 2 as AB. The catch is that the greatest common divisor among this is the AB part. Why? Because we can form string 2 and string 1 both using the repetition of the string AB multiple times, right? Now if we look into the third example, the string 1 over here is leet and string 2 is code. Now they have no common repeating pattern, hence we do not output anything. Right, so the key observations over here of this problem. So the first things first is that the string 1 and string 2, to have a common repeating pattern, their concatenations should be independent of the order, right? So if I concatenate string 1 and string 2, that should equal to the concatenation of string 2 and string 1. So it should be order independent. That's first check. The second observation that we can make is that if they do have a common pattern, the length of the greatest common divisor string will be what? It will be the GCD of their individual lengths, right? So in this case, if you can see, the string 1 has length 6 and string 2 has length 3. So the GCD is the length of the GCD is the length of the string 1 and GCD of the length of string 1 and length of string 2, which is GCD of 6 and 3, which is basically 3. Now let's quickly understand how the Euclidean algorithm help us compute the GCD efficiently. So the GCD of two numbers is the largest number that divides both of them without leaving a remainder, right? So for example, okay. So for example, let's say we have GCD of 48 and let's say 18. So what will be the GCD of these two? The GCD of these two will be 6. Okay, now how are we achieving this thing? So there are three exact steps that we follow to find GCD. Step number 1, we divide the larger number by the smaller number and take the remainder. Step number 2, we replace the larger number with the smaller number and replace the smaller number with the remainder. And step number 3, we repeat this until the remainder becomes 0, right? So for example, let's derive the GCD of 48 and 18. How did we reach to 6? So what is the first step? The first step is to divide the larger number by the smaller number and take the remainder. So basically what we will do is we will do a modular operation. So 48 modular 18 is what? It is 12. So what we will do, we will replace this 48 comma 18. So what we will replace the small larger number by the smaller number. So we are replacing 48 with 18, and we are replacing the smaller number with the remainder. So we are replacing 18 with 12. So this is our first step. Now since the modulus is not zero, we will repeat the same step. So we will do this for 18 and 12. 18 modulo 12 is 6. So we will again do the replacement. We will replace 18 and 12 with 12 and 6. And still the remainder is not 0. Hence, since the remainder is not 0, we repeat the steps. And here we have a stop. Why? Because we have reached 0 remainder. So the GCD is 6. So this is what the Euclidean algorithm looks like. So this algorithm runs in big O of log of minimum of A and B, right? So which is pretty efficient, right? So okay, let's implement the solution using the Euclidean algorithm. Let's code it up. Fine. So before getting into the main part, let's define a function inside the function that is given to us. So let's define this function to handle it efficiently. So we will define a function find GCD. We are going to take two inputs from two numbers. So we are running a loop while b, and we are replacing the larger number with the smaller number and the smaller number with the remainder, and we will return a. Okay, so we have implemented the Euclidean algorithm to find the GCD. Now what we are going to do, we are going to check if they have a common pattern, the string 1 and string 2, if they have a common pattern or not. So if there is no common pattern, string 2 plus string 1, right? If these two do not match, then they do not have any common pattern, and we are going to return nothing. But if they do, then we will find the length of the GCD. We will find the GCD of the lengths of those two strings. So we have already defined the GCD function earlier. So we are just going to take the lengths of these two, and we are going to find the GCD of the lengths. Now we have got the GCD, we have calculated it using the Euclidean algorithm. Now what is left is that we need to return the string, that is the GCD. So what will be the GCD string? So the GCD string will be the prefix of the string 1 up to this GCD length that we have just now found out. So we will simply return string 1 till GCD length. And that should do it, I think. So let's go ahead and run this code. Yeah, it is passing these 3 test cases, and now let's submit and check whether it passes all the test cases or not. It should. And yeah, it passes all the test cases. So the solution is very efficient, because let's discuss about the time and space complexity to make you understand why this solution is very efficient. So what we are doing here is that we are checking if both of the string have any kind of pattern or not. So this if loop is giving us a big O of n plus m, where n is the length of string 1 and m is the length of string 2. Computing the GCD manually using this find GCD function is giving us around a log of minimum of a comma b that we just discussed previously, and extracting the substring here at the last line, it takes around big O of k, given that the k is the GCD length. So the overall complexity becomes big O of n plus m, which is pretty efficient. So if we quickly recap what we have done, so we have checked if the string 1 and string 2 share a common repeating pattern or not. Then we have manually computed the GCD using the Euclidean algorithm, and we finally extracted the first GCD length characters from string 1 to get our answer. So there you have it. So if you found this explanation helpful, don't forget to like, share and subscribe to the Data Couple, and comment below, of course, on what would be your approach to this solution. And yeah, I'll see you in the next video.